Those of you who don't know me, my name is Wasim Asgar. I'm a licensed professional engineer in the US and Canada. I have helped thousands of engineers over the last 10 plus years prepare for FE Electrical and PE Power exams. My study guides for FE Electrical and PE Power are some of the best rated, highest rated books in their categories on Amazon. And I also run popular exam preparation programs for both FE Electrical as well as PE Power exam prep. So why is circuit analysis important for FE Electrical as well as the PE Power exams? Let's first focus on FE Electrical. What is the significance of FE Electrical for circuit analysis for FE Electrical? Circuit analysis is one of the big five topics. I coined this term Big Five about 5 years ago when I released the third edition of my study guide for FE Electrical, I believe. And every now and then, when I interact with students on LinkedIn, when I interact with students on, let's say, Reddit and whatnot, when I onboard my students, I use this term quite a bit. And I've noticed a lot of other people kind of using it on Reddit and social media platforms and whatnot. So the big five sections for FE Electrical, those of you who don't know, are your mathematics, your circuits, your electronics, your power, and your digital system. So circuits is the second of the big five topics. It has one of the highest weightage on the exam, and collectively these big five topics account for about 50% of the entire exam by weightage. There are a total of 17 sections on the FE exam, and circuits alone is about 10% of the entire exam by weightage. So that's the obvious reason why it's important. Now, the foundational tools that we have to rely on, that we are tested on, that we need to know in circuit analysis are KCL, KVL, MASH, nodal, Thevenin, and Norton. And these concepts do repeat across other sections. Electronics, another big five topic, roughly 10% by weightage, has about 70% of most of its problems based directly and indirectly on circuit analysis. Power systems heavily on circuit analysis. Linear systems, RC transients, heavily on circuit analysis. I've got this small request for you. 77% of you watching right now are not subscribed to the channel. That's a massive number. If this video is helping you out in any shape, way, or form, please do me a quick favor. Please hit the subscribe button and ring the bell. That way you will not miss out on any content that we've got planned, and it really supports the channel. Now, here's the thing that a lot of people don't understand. That circuit analysis requires deep understanding, not plug and chug. Creating frameworks is helpful, but only if they are grounded in deep understanding. Pattern recognition is helpful when it is grounded in deep understanding. If you are continuously playing at the back of your mind kind of templates in which you are trying to force certain circuit analysis problems into because you've done some similar type of problems, it will almost always prevent you from actually learning them. Okay, this has been my observation helping students over the years. So we need to focus on our deep understanding, not plug and chug and not just simple frameworks. Mastering circuit analysis is the fastest way to build that solid foundation for FE Electrical in terms of its weightage, in terms of, its overlap with a lot of other topics. And I would say this is the single most important section in the entire FE Electrical and computer exam specification. So that's kind of the motivational talk for FE Electrical, importance of circuit analysis in that particular context. Then we have PE Power, which arguably is the more difficult of the two exams. In the context of the PE Power exam, I think it's important jumping right into this pretty bold statement that I have basically made, that without fluency in circuit analysis, it's borderline impossible to pass the PE Power exam. I don't think anyone can pass the PE Power exam without having a solid foundation or in circuit analysis. It's basically the language for every power systems problem, underpins advanced power system concepts. So at the FE Electrical level, KCL, KVL, DC analysis, Thevenin and Norton, that's basically the name of the game. In our power systems section of the exam specification, we deal with single phase, three phase, delta Y configuration, transformation. Everything is balanced, very neat and clean. But when it comes to the PE Power exam, your three phase is sort of the foundation, background, assume knowledge, and then we quickly build upon it in the form of per unit systems, in the form of symmetrical components, in the form of fault analysis, symmetrical and unsymmetrical faults, in the form of power flow, power system stability, protection. So things do move really quickly in PE Power because we tackle advanced concepts, not just the very basic fundamental Thevenin and Norton. And the basic Thevenin and Norton does play a role in, they do play a role in transformer modeling, motors, and when we are analyzing the circuits. Interestingly, every single technique that we use in the context of circuit analysis, whether you're doing DC or AC, whether you're doing balanced or unbalanced systems, everything boils down to just one simple principle, the most basic electrical engineering principle. You guys know what that is? Almost everything is just going to distill down to one particular principle. It is the good old Ohm's law. Okay, I don't want to digress too much, but at the end of the day, whether you are doing AC analysis, right? So you have a sinusoid, we use RMS transformation to bring that into effective DC. When you have DC, whether you're doing KCL, KVL, mesh, Norton, Thevenin, superposition, anything, the underpinning is Ohm's law. At some point, you will be finding yourself using V is equal to IR, V is equal to IZ, or I is equal to V divided by R. Okay? That is for balanced systems. That is true for DC systems, AC systems. What about unbalanced systems? What if you have three-phase rather than single-phase? What if you have faults happening? What if you have SLG happening? What if you have a double line to ground fault happening? What if you have a line to line fault happening? Even in every single one of those cases, every single one, whether you're doing per unit or symmetrical, it always comes down to Ohm's law. And this is one thing that I try to emphasize, especially to my PE power students, that no matter how far you go in terms of your analysis, and I actually have created ETAP courses as well for short circuit, load flow, and R flash. At the end of the day, it is all about Ohm's law. But being able to see that simplicity requires in-depth understanding and foundation, where you are able to bring everything back to the basic principles. Okay, so no matter what you're doing in terms of short circuit calculations, fault protection, coordination, everything, it really comes down to Ohm's law, comes down to fundamentals of circuit analysis. So in summary, circuit analysis is tested directly on the FE electrical and computer exam. I mean, we have a dedicated section called circuit analysis. In fact, we do have analysis in section number 4 of PE power exam specification as well, and it applies everywhere on the PE power exam. Okay, so if you master it once, it pays you back throughout your entire career as an electrical engineer, gives you that confidence and that deep understanding. So that's why circuit analysis is super important for FE electrical and both PE power exams. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, studyforfe.com.